Alright, here's another one of these summary problems where we're trying to find out which thing is more volatile. We'll talk about that in a minute, but first we're just going to start by drawing the Lewis structure as before. So Br2, we're going to find the budget. Br normally has 7 valence electrons, so Br2 would have 14. CBr4, C would have 4, and then 4 bromines times 7 would be 28 for a total of 32. So we have a budget of 32 for CBr and 14 for Br. As far as the central atom for Br2, it's not really relevant. I'm just going to connect 2 Brs to start, and then we're going to add dots to get them all to 8. So this thing's going to need 6, and this one's going to need 6, because the line counts as 2. We're going to check our budget, 2, 4, 6, 8, 10, 12, 14. It checks out. This Lewis structure looks good. Next one, carbon's going to be our central atom, because it often is. Often the unique one, so we'll connect each of the bromines to carbon. We got to make sure each atom has 8 electrons. So there's 2 here, so I'm just going to add 6 to bromine, 6 to this bromine, 6 to this one, and 6 to this. Carbon has 4 bonds, so it already has 8 electrons around it, so it's good. Check our budget. There's 8, 16, 24, 32. Budget checks out. This Lewis structure looks good. Now let's find the shapes. Well, 2 atoms attached to each other is pretty simple. It's just linear. There's really no other shape 2 Brs could make. CBr4, we count the groups. There's 1, 2, 3, 4. Again, a tetrahedral basic structure. So carbon, and it's basically looks like a little bit of a tripod. This one comes out. This one comes away from us. 3 of them go down as in a tripod, and 1 goes up. So that's that shape. Okay, now we're going to determine whether each of these molecules is polar or not. So Br has an electronegativity of 2.96. Obviously, so will this one. So their difference is 0. That makes this a non-polar bond, and since it's the only bond in the molecule, that means that this substance is also non-polar. Now let's look at CBr. So C is 2.55. Bromine is 2.96. So the difference here is about 0.41. It's right on the border, but it is enough to make the bond polar. So each of these bromines is going to be negative because they're taking electrons from carbon. Carbon's going to be more positive. If we draw arrows from the positive towards the negative along each bond, we'll see they all go in totally different directions. Also, there's no way to divide the positive and negative sides of this molecule. Like the positive is in the middle of the molecule. It's surrounded by negatives. So that's also going to lead us to believe that this is a non-polar molecule. And since they're both non-polar only have London dispersion forces for IMFs, which are very, very weak. So we have to compare these two. So they both have the same types of IMFs, so the question is which one's stronger. And the sort of tiebreaker for this is a larger molecule, one with a larger molar mass and more electrons, tends to have stronger IMFs. So CBr4, without even doing any math, has a higher molar mass than Br2. So this one is going to have stronger IMFs, meaning these molecules are going to cling to other molecules of the same type more strongly. Now the question is, which one's more volatile? A volatile substance is a substance that readily becomes a gas. You have a liquid and it just vaporizes very easily. Gasoline is something that's volatile. It will vaporize easily. So if these particles cling together really well, then they're going to be hard to break apart and vaporize. So as far as which one's more volatile, it'll be the one with the weaker IMFs, which is Br2. So again, that's the analysis we go through every time. You have to find what types of intermolecular forces there are in each molecule and basically compare them. And so that's it. So until next time, I am Derek Genova. Have a delightful day.